In this lesson, we're going to be looking at ionic equations, and there are two types. There's a complete ionic equation and a net ionic equation. We're going to learn how to write those from single replacement and double replacement reactions. So you have to be able to classify equations and balance them before you can do this lesson. So there are two kinds of ionic equations. All right, so here is a complete, here's an equation for double replacement, okay? We've already learned how to balance these. That's why I didn't give you this one to do. But I'm giving you this because I'm going to show you how to take this and from this write a complete ionic equation and write a net ionic equation, okay? So if you want to take a second and write that down, it'll be helpful because you're going to need to be able to take something like this when you do it and break it up into ionic forms. So you may recall when we were explaining the driving forces for double replacement reactions and how to predict the products of a double replacement reaction, that I showed you that this chemical, when you put it in water, if it's aqueous, is going to break up into its separate ions. Okay? Well, writing a complete or net ionic equation is just doing this stuff, finding the ions that are formed from this. Now, and that is just the reverse of how we learn to write balanced formulas to start with. When we're learning to write a balanced ionic formula, that is a charge balanced ionic formula, we wanted enough of these hydrogen ions with a 1+ charge to completely neutralize the 3 negative charge on that phosphate, so that the compound we end up with has an equal number of positive and negative charges, and it will be neutral. Well, that's what we're going to do here. The difference here is we're going to use all of the ions. In this case, I was using just the ions in the formula, but I didn't count the fact that I had 2 formula units. Now we're going to count the fact we have 2 formula units. So in this case here, this is an aqueous ionic compound. This ionic compound has 1 calcium ion. We know it's ionic, by the way, just to remind you, because we have a polyatomic ion. So this is an ionic compound. We've got a calcium with a 2+ charge, but there are 3 of these formula units. So how many calcium ions actually are represented in this equation? 3. So we've got 3 calcium ions, each with a 2+ charge. If this compound, this formula unit, breaks up into water and it's aqueous because it's dissolved in water, well, by the same definition, then the ion's aqueous because it's been dissolved in water. So we're going to call it aqueous as well. All right. And how many chlorate ions do I have here? 6 of them. There's 1 inside the parentheses, the 2 outside the parentheses means there's 2 of them in the formula. The 3 here means there's 3 of everything, so that's 2 times 3 or 6. So we've got 6 chlorate ions. And they each have a 1 negative charge. And since the formula is aqueous, then that ion's aqueous. Okay? So I'm going to give you guys a second. I'm going to let you try to break this one up.
Which one? Is this thing?
The aluminum chloride. Break it up.
Wow.
Let's see how you did. I see 2 aluminum ions. They each have a 3+ charge. And I have 6 chlorine ions, or chloride ions. Did you get that? Like I said, this is not really hard, is it?
Do you just know that it's aqueous because it...
That's aqueous.
So that's
If the formula unit is dissolved in water, then the ions have to be dissolved in water because that's how they happen. Okay? Well, let's break this next one up then. Let you. All right, let's compare what you did here with what I'm about to do. So I see that I've got 2 aluminum ions here. And I've got 1 chlorate here times 3 is 3 times the 2 is 6, so 6 chlorate ions. Okay, did you do okay with that?
Yeah.
All right, good. Now the last one is not aqueous. Okay, if it doesn't dissolve, ionic compounds don't break up. So that last one, we're just going to write it the way it appears there. 3 calcium chlorides that are solids. Okay? Now, this is a complete ionic equation. How do you tell what?
It's completely in that.
If you've completely broken everything up, that's a complete ionic equation. That makes sense?
We didn't break up the 3 CaCl.
But you can't break it up because it's a solid.
So it's not completely broken up.
No, it's completely broken up because only the aqueous stuff breaks up.
Oh.
Okay? All right. The net ionic equation then excludes all of the spectators. Well, what are spectators? The people that are sitting around watching, right? They're watching the action. They're not really participating in the action, right? Well, let's look at this equation here. Do you see anything that's just kind of not really doing anything? The what one? Well, no, the solid, that started out as aqueous, and this joined up with this and formed that solid. That's doing something. The aluminum, yeah, it's aluminum through ions on both sides. They're not doing anything. They're sitting around watching the calcium and the chloride do something. Okay, aluminum's a spectator. Okay, any other spectators here? Not the chlorine, but the chlorate. I'm sorry, I might have misunderstood you. Okay, so those are the spectators. The spectators we're going to leave out of the net ionic equation. Okay, so we said calcium and chloride are the only ones that actually do anything here. So our net ionic equation is going to look like this. Okay? What? That's it. That's all there is. Now look, if there's nothing to cancel, and that happens sometimes, you might have an equation where there's really nothing to cancel. In a case like that, then the complete and net ionic equation are the same thing.
So, do you have to do the complete to figure out the net?
If you do this long enough, you can do the net without having to do the complete. But yeah, when you're first starting out, you've got to do the complete first. You got it. And then as you might expect, I expect you to always do a complete before you do a net. Okay? Yes.
So in this class, do you expect us to say aluminum or aluminum?
I don't care. So the question is, do I expect you to pronounce it aluminum or aluminium?
That was a dumb question.
Why is that a dumb question? It's not a dumb question at all.
Obviously, that's a dumb question.
If anybody in here that is from a country other than the United States would call it aluminium.
So now she's being racist against me.
Okay. So
What you're saying is you're a racist.
here's an equation that I did earlier, and you can see that there's no aqueous stuff on the right hand side. So nothing is a spectator here. So this is a complete ionic equation and the net ionic equation. Okay? That's what I'm saying. All right? All right, so now the nice thing here is there's only two kinds of equations that even have ionic equations. Only two classifications of equations even have ionic equations. Okay? Now, there are cases to be made where you have synthesis reactions that have ionic equations and decomposition equations that have ionic equations, but we're not going to do that in here. All right? for us, we're only going to have to do ionic equations for two classes of equations, single and double replacement, or single displacement and double replacement, okay? So when you classify the equation, if it's not double replacement, or if it's not single displacement, you don't have to write an ionic equation. You follow me? That makes sense? All right. So what kind of equation is this? Which classification does this fit into? Single displacement. Because I've got a single thing by itself and it displaces something that's like in this compound. Okay? I've already balanced this one for you as well. And all we're going to do now is to try to write the complete and net ionic equations for this. So we'll give you a couple minutes to work on that.
I need the problem.
How'd you do? Wait. Okay.
Why did you put?
Okay. The reason I didn't put a 3+ on the first aluminum is because an element that's by itself has no charge.
Then what? Then why is lead?
An element by itself has no charge. This lead is actually charged because it came from this compound. This aluminum is charged here because it came from that compound. Your homework is going to come from this list.
No.
What do you mean, no?
No.
So these are the problems we're doing from the text on the website, page 228. So you're going to pick the numbers corresponding here on this list. 9, 17, 18, 19, 21, 23, 24, 30, and 32. Two things I need to tell you. Okay. One is these are numbers from your text for this unit. Okay. So these problems on page 228 are the ones you're going to do for homework. You're going to balance the equation, predict the products. If there is a net and complete ionic equation, you got to write those. Okay? So here's a tip. There are net ionic equations for only two types. There are only net ionic equations if you have a single replacement, double replacement reaction.